Okay, my name is Martin, and in my session I'm going to present how we integrated openEuler with OpenHPC project for doing high-performance computing on openEuler. A few words about me. I'm Martin. I'm a software developer from Bulgaria. I do it professionally since 2003. I'm a member of the Apache Software Foundation. I commit in 4 projects there. I work with openEuler since 2020, and I'm maintainer of OpenHPC projects, maintaining the openEuler part of it since 2023. And lately I work mostly on Bioconda by helping there to add support for many projects to support ARM64 architecture. What is openEuler? I believe everyone here knows what it is, but quickly, it's a modern open source Linux distribution that could be used for almost any scenario: cloud computing, on-premise computing, edge, embedded, and last but not least, some people also use it for desktop. What is HPC? HPC stands for high performance computing. This is a way to engage a lot of compute nodes with modern hardware to do large-scale computing to calculate some complex stuff. It's used mostly for scientific research, for example, for weather forecasts, for artificial intelligence also lately, gene sequence, image processing, biopharmaceuticals, and doing many different kind of simulations, airflow, water flows, and such things. This is a simple diagram of an HPC cluster. Usually you have the system management server, SMS. Yeah, this is a specific terminology in HPC. It's also called master node, head node. It's responsible for administrating the compute nodes and to install software. And then you have a lot of compute nodes. Usually, as I said, they are high performance with modern hardware on them, and they are connected via high bandwidth, low latency network. In addition, there is also baseboard management controller based networking. So the master node can boot the compute nodes remotely from the network. The operating system is installed on the fly with the booting usually as well. And yeah, once everything is set up and running, the master node just sends tasks to the compute nodes to calculate different kind of problems. How did it start? openEuler with OpenHPC. Around December 2022, the Lanzhou University from China contacted us to ask how to use HPC with openEuler. We did some research and we decided to contact OpenHPC project. It's February 2023. We discussed with them that we want to add support for openEuler to OpenHPC. The project approved our request and we started working. In the next several months, we worked on adding support for different kind of HPC related software on openEuler. We faced some obstacles when doing the task. Some tests were failing. We had to investigate why. Most of the time it was mostly because there were missing dependencies. That is, openEuler package repository didn't provide some dependencies, so we had to add them. Some of them are added now in the official repository. You can just use DNF install and install them. And some of the others, which are more HPC specific, are in external repository that is maintained by me. And at July 2023, the integration finished. And later that year, at the Software Computing Conference, November 2023, OpenHPC version 3.0 has been released with official support for openEuler 2203. What is OpenHPC? The project is a software repository that provides HPC-related software packaged for 3 different operating systems. Those packages are for 2 different CPU architectures. It provides several compiler families, some of them with more than 1 version, and several MPI implementation. MPI stands for Message Passing Interface, and it's an architecture for inter-process communication between the compute nodes. So one node computes something, then it sends the result to another node to do something more, and it do it in a high efficient way. It uses several provisioners. The provisioner task is to create the operating system on the master node and then provision it, copy it, let's say, to the compute nodes and boot them. Several resource schedulers, that is, when starting a job, HPC-related job at the master node, you can say, I need that amount of compute nodes with these hardware requirements, and the resource scheduler will automatically calculate, decide which nodes to use and whether it can serve this task at the moment or it should wait a bit. And in addition, OpenHPC project provides documentation in PDF format that gives you step-by-step documentation how to set it up, and also bash shell recipes that you can use to do it automatically without copy-pasting those commands. And those recipes we also use for integration test. The project is a member of the Linux Foundation, and its members are several big software and hardware vendors, and also several universities and scientific laboratories. The project is managed by maintainers, technical maintainers, 1 project and technical lead, and several technical maintainers, that is, people who know different parts of the technologies, and several end-user representatives, mostly from the universities and the labs, that actually use HPC, and they provide ideas and advices how to improve things. There are 3 major versions of OpenHPC. 1.x, that is not supported anymore. It has reached its end of life. 2.x, this is the most used one at the moment, and 3.x, the latest, that's also added support for openEuler. The project has started 2016, and since then its adoption grows each year. This is the number of visitors per year, and also similar diagram, how many packages have been downloaded from the repository. So it grows. And here is a list of software components in OpenHPC 3.x. As I said, there are 3 operating systems being supported: Red Hat Enterprise Linux 9, OpenSUSE Lib, and openEuler 2203. The common between them is that they're all RPM based. So, for example, Debian and Ubuntu is not supported due to different packaging. We support 2 different CPU architectures, x64 and ARM64. Compiler family is the GNU compiler family, and also Intel for x64 and ARM Alinea Studio for ARM64 when you use specific hardware. CLang has been also supported in the past, but there were some problems, and at the moment it's disabled. MPI families, this is, as I said, the message passing interface in architecture. We support the most famous ones: OpenMPI, MPI-CH, and MVA-PI-CH2. Intel MPI has been disabled due to some problems. For provisioning, we use Werewolf version 3. There is some work to add support for Werewolf version 4, but it's in progress now. XCAT is another provisioner that, Werewolf is supporting stateless provisioning. That is, it installs the operating system on the compute node in memory. So each reboot installs a fresh copy of the operating system. And XCAT, for example, it supports also stateful. That is, it installs the operating system on the disk, and if you need to use something, you can. But it's not supported anymore, and we work on Werewolf 4. Resource management and scheduling. Slurm is the most common solution here. We support it. In addition to it, we also support OpenPBS and a few others. Usually the compute nodes communicate between them, not communicate, they use network file system, so any input and output that they have to use is on network file system. We support also Lustre and BGFS as more performant ones, and some others. And this list is not full. That is, if you need any additional software that is not provided by OpenHPC, you can use EasyBuild and SPAC to install it. How to get started with OpenHPC? If you go to the GitHub repository, release pages, we have such kind of URLs for PDF files. The base operating system, the provisioner, the resource management, and the version. So, for example, openEuler 22, Werewolf, plus Slurm. Once you download it, this PDF file, you can follow the steps and install the master node and compute nodes. But if you want to automate this and make it quicker, easier, then you can just install the OHPC docs package, and it provides the recipes, which is a shell script that you can just run, and it will automate a lot for you. That's the main purpose of OpenHPC, to make it easy to start with your HPC computing. What to expect in OpenHPC 3.2? As I mentioned already, Werewolf 4.x. The difference with Werewolf 3 is that it's container-based. That is, you can use any OCI container for the compute nodes operating system. But again, it should be based on the supported operating systems. That is Red Hat, OpenSUSE, and openEuler. But you can pre-install something more in the container, and this way it will be faster to set up your compute nodes. There is no need to install at startup time. There is also some work by Lenovo to add another provisioner, Confluent, their own product. It's again stateful, something like XCAT that is no more supported. There are some improvements in the profiling and monitoring area with the tools like Scala, Scorpy, Opari2, and PubeGUI. And usually with each release, we also update the versions of all packages in the repository. That is, we update to the last supported version and retest everything. And there is some work to update our documentation generator, because currently it uses LaTeX for this, and this is, I would say, a bit too scientific, and it's not very user-friendly technology. So we try to migrate to Markdown-based generation. It's more popular these days. How to reach us? You can do it at Slack. This is our Slack server, and we have a channel there specifically for openEuler. We have mailing lists, and you can raise issues or send pull requests at the GitHub repository. If you have an idea about adding yet another HPC-related software to OpenHPC, then there is a special GitHub project submissions under the OpenHPC organization, and there we discuss any proposals. They are discussed in the technical steering committee, And once approved, we start adding it in the main repository. And yeah, that's for me. If you have any questions, I'll be glad to answer. Yes?
So I have a question that our HPC solution, right? Do we use the scheduler? Do we support Slurm or some scheduler that you develop it yourself? And what's the difference between does it have any advantages than Slurm or other schedulers?
I believe Slurm is the most popular, most used one in HPC. The second one is PBS. We don't have any custom solution here. For example, if there is another one, it should be open source solution. We cannot use something that is internal for proprietary for some company. But yeah, if you think there is a better solution, then you can submit it here at submissions and say, I have an idea, let's add support for this third resource manager. I believe it's better for this and these reasons, and then it will be discussed. But at the moment, yeah, I would say the most popular one is Slurm, and most of the users use Slurm. Some of them use PBS. I have seen some questions in the mailing list, but Slurm is the most popular one. By we, you mean, I guess, the university that I mentioned earlier, or who? The university. Because we, in my case, is we use both. I mean, as an OpenHPC project, whenever someone sends a pull request, either external user or internal developer, maintainer, we run integration tests. And this integration test, they test openEuler with Werewolf plus Slurm, with Werewolf plus OpenPBS, or vice versa. And we try to test the whole matrix. That's the idea of the components here. When you set up an HPC cluster, you usually use one operating system and you run on one CPU architecture. Then some projects use GNU compilers, another project uses, let's say, Intel, and all this can be pre-installed on the compute nodes, and then different researchers, scientists can say, I want to run my job, but my job requires a GNU compiler and Boost library that is built for OpenMPI. And this is managed on environment level by using a tool LMOD. I'm not sure whether you know it, but yeah, the idea is that it automatically says, it says at the moment on the system we have pre-installed several compilers and several libraries, but this specific task, it needs to use just subset of them. And just those are made available on the path and LD library path, and those visible for usage. But otherwise, we test all those for openEuler, and we make sure that all of them work. That means their test passed. If the tests cover a lot, then it's better. If the tests don't cover much, we cannot catch some problems. Yes?
So, because there are like 3 base OSs.
Yes.
So, what's the cost if I'm a user, I want to shift my workloads from, for instance, Red Hat Enterprise Linux to the openEuler environment?
So the question is how much effort is to switch from one OS to another OS? Just to repeat for people in the back. It depends on what kind of additional software you use. So if you use mostly the software that is provided by OpenHPC, it should be quite easy. But if you use something in addition that you install with Easy Build Pack or manually or anything like this, then we don't know what kind of problems to expect. So yeah, it depends on how much on top you have. But otherwise,
are there any tools to for example, if you are doing some other workloads, there might be a tools that can check whether what's the compatibility and what's the suggestion, whether you can move or not.
Yeah, I'm not sure about this. The easiest way for me would be to just run the recipe and see what kind of problems it faces during the steps. There might be even some hardware-related incompatibilities, because I know, for example, currently in the project we use several ARM64 base metal machines for the testing, and for example, Rocky Linux and Alma Linux work just fine, version 9 I mean, work just fine, but Rocky and Alma version 8, they don't even boot. That is, they don't have some drivers for the hardware, and we cannot even boot them there. But we didn't spend much time because, yeah, we tried to focus on the latest version. Currently version 2 is in maintenance mode, that is, we fix some minor issues here and there, but not much more. Yes?
Have you heard the new architecture for RISC-V and any roadmap to support the RISC-V open standard?
I have heard of it, but at the moment no one asked so far in our technical committee. Yeah, we have meetings every 2 weeks, and so far no one mentioned it. No one asked for support for it. If someone asks, then yeah, I guess they'll have to provide hardware for it, because at the moment, at least I'm not aware whether any of the other hardware providers provide it. And yeah, start discussion how to add support for it. But at the moment, I don't recall anyone asking for it.
Actually, it's kind of weird because, you know, some of the HPC data centers in Europe starting to use RISC-V architecture.
Then I guess pretty soon someone will contact us and say, let's add support, I guess. Thank you.